Well, please. Okay.
John. So guys, we have a speaker today all the way from Rhode Island, Ithaca, Connecticut. I'm not entirely sure. He's been around today quite a bit. So please welcome Victor Aprea, please.
Yeah. Hey guys, how's it going? You guys are doing some really cool projects. I got to talk to some of you personally.
You're being recorded for our YouTube channel, so if you have anything that is IP that you don't want to share in the Q&A.
Yeah, not really, because it's more like I do a lot of, well, I'll talk about it, is I do a lot of what's called open source hardware. So not a lot of stuff to hide from you. But yeah, you guys are doing some really cool projects. It's really exciting. I mean, when I was your age, to a lot of what you're working on, physical computing, microcontrollers, that was really, you had to really go outside the box to find information about it. And like, even if you went to the public library, it was hard to find. So the first time I ever actually wrote a program was in high school. And I wasn't sure if I was going to, I kind of knew I wanted to be an engineer. I wasn't sure what kind of engineer I wanted to be. So I liked programming, I liked building circuits. I took an electronics course in high school. And so the coolest thing was my electronics course in high school, where first it was kind of a combination of electricity and electronics. So they taught us how to wire houses, but they also taught us how to like put together circuits and make LEDs blink. That's sort of what it felt like it was, right? It was like how to make an LED blink in 100 different ways. And so I really enjoyed that. And when I went to college, I was deciding between computer science and electrical engineering. And for me, I really liked making things actually happen in the real world. And I felt like when I was doing programming, a lot of my time was just spent debugging on a screen, and it wasn't very interactive with the physical world. So that's what pushed me into the world of electrical engineering. So I went and did electrical engineering, and what you find when you go into college, even if you pick a subject like electrical engineering, it's very broad. There's like a million different things inside electrical engineering you can get into. You know, people in electrical engineering work on the power grid. Some of them work on just doing like math, basically doing digital signal processing. And then some people work on electronic circuits and making physical interactions happen, so like microcontrollers and things like that. And it wasn't until my junior year of college, actually, that I got into a class in microcontrollers. And at the time, it was sort of like this new class that had never been taught before. This was like 12 years ago. So really not that long ago, right? So this stuff has really been emerging quickly and kind of changing the way education is. So yeah, so I took this course in microcontrollers, and I kind of fell in love with it. And because it really gave me the chance to do programming, which I really do like to do. But at the same time, it gave me the opportunity to interact with mechanical components. And actually, for my final project, for example, I did a whiteboard-mounted plotter. So it had two stepper motors in the corners, and it moved a marker on the board and drew pictures based on input commands on a little keypad and an LCD. And since then, I've seen like other much more sophisticated versions of that concept. Like I went to Maker Faire 2 years ago, and I saw this high school kid who had made a similar project, but it was making like works of art, like beautiful drawings on a whiteboard. So that's the cool thing, right? Is like you can kind of research the web now, and you can find projects and do derivative works and make things better. And contribute back, right? That's the other cool thing, that you can contribute back to the community, and people can build on your work too. So anyway, after college, I did my master's degree. I got another master's in electrical engineering. Most of that was, I mean, it was a combination of the timing. Like around 2002, when I graduated, the job market was a little bit soft. I figured I wanted to go back to school at one point, so I might as well do it now. And after grad school, I got a job with Lockheed Martin, and I was an electrical engineer for Lockheed Martin, worked on helicopter systems and embedded electronics for aircraft, so kind of avionics equipment, things that sort of tell the pilot what their flight situation is, right? So how you fly the plane, if you're looking out of a cockpit, a lot of what you do is stare at a screen. You don't look out the window. And the screens tell you if you're flying straight and level, where you're heading, kind of your mission plan and things like that. So I worked on cockpit displays and controls, and I've also worked on embedded computers for aircraft. So kind of a very specific market, I guess, right? Like the electronics that go in an aircraft are very well understood, and sort of, it's not about like making the cheapest thing in the thousands of quantities. It's about like making 4 of them work really well, and like can work over a large temperature range and pretty much like never fail. And then so while I was working at Lockheed, I started doing electronics for hobbyists, right? Like for people like you and me, because in my spare time when I wasn't at work, I was home kind of playing with Arduinos, doing embedded electronics, and just kind of playing with LEDs, just like what I really loved to do when I was kind of just learning electronics. And the first project I did, well, so let me back up a second. So a friend of mine wanted to learn about electronics, and we knew each other because our wives were in the same book club. So we decided, hey, you want to learn about electronics? I'd like to do electronics. Let's get together and kind of do electronics on the weekend. So first thing I did was I made a binary clock with him. So I made a little electronic circuit with a microcontroller embedded in it that told the time in binary code, because I just wanted one on my desk, right? I just wanted to put one on my desk to confuse people, basically. And so we called it the Minty time, and after doing a few projects like that, we just started talking to each other and saying, I wonder if other people would like to build these kinds of little projects for themselves. And so we decided to start a little business on our own called Wicked Device, which is, now we're like 3 years old. And we make all sorts of like hobby electronics projects that you can put together yourself. We make some things that are kind of finished that you can just put together out of a box and like put on your desk and they work. And the most recent thing that we did is, I guess it's like last May, we did a Kickstarter project, which is, I mean, you guys all know what Kickstarter is? Have you heard of it? So I mean, it's a really cool way to get funding to do big projects. And we got involved in a project called the Air Quality Egg, which was a way for people, like citizens like you and me, to measure air quality in their own home, right? Because like if you go around, you can see the government, the state has air quality monitoring stations, maybe 2 or 3 in each state, and no one really has a good grasp of like what the air quality is like locally to them. So we wanted to create a network of several air quality monitoring stations that you could kind of look at across space and time what your air quality looks like, how it changes over time. So that was kind of like the last year and a half of my life, was sort of developing the hardware from scratch and writing this firmware for it, and sort of engaging with the community to see what the holes were and how to make it better. Yeah, and then that's all kind of built on Arduino type of hardware, Arduino derivative hardware. So we make the heart of that processing is in the Air Quality Egg is a product called the Nanode, which is an Arduino that has an Ethernet connection in it. So you can just plug a network cable in and basically make a little tiny web server running on an Arduino. So that's the kind of stuff that I have gotten into and that I've been doing for the last 10 or 15 years. And I'm excited to see like so many kind of cool projects going on here. It's like the beginnings of, I can't imagine what you guys are going to be doing in 10 or 15 years. So I'll open it up to questions, I guess, at this point. Yeah.
You said earlier that like you do a lot of open hardware stuff. So I always ask this to people who talk about that.
Mm-hmm.
Like, how can you like sustain or like make money off of open hardware? Like, I understand open firmware is like I get it a little bit more, I guess. But like open hardware, that's like something completely different. So like, how does that work? And why did you choose to do that?
Yeah, so it's a really fairly new concept, I guess, right? So the idea of open hardware has only been around probably for 5 or 6 years, I would say, in a serious capacity. So how does open software make money, right? Like the biggest example of that, I guess, is probably Red Hat Linux, or what was the...
I feel like they have advertisements and other stuff that they
Sure, but the other big way people can make money in open software is like a support model, right? So you make a really good product and you keep innovating on it, so that the idea is that the stuff that if the stuff you work on is sufficiently simple, right? If you're building on Arduino technology, or if you're building on circuits that are not like inherently really complex, they don't rely on like deep research and development of lasers or something like that, the chances are someone's going to be able to look at it, right, and figure out what it's doing anyway. So if you put it out in the open, first thing is like your intellectual property is sort of a little bit safer, right? Like a big company is not going to be able to attack you as easily. And having kind of private information also has a cost, right? You need to be able to defend that in a courtroom. And you know, if you're a small business and you have hardware is what you're trying to produce, I mean, there's an argument to be made that you can't afford intellectual property, if that makes any sense, right? But I mean, there's, you know, it's always something you have to think about. Just because you're an open hardware company doesn't mean everything you make has to be public. And there's other kind of angles on it that are to the tune of, you know, make public what needs to be public, right? Make what's valuable to your audience and your consumers public, right? If you want to have an audience that really wants to know how something works, well, you know, making a binary clock that no one can like look at the schematics and see how it works, you know, your audience isn't going to really care, because they could buy an off-the-shelf binary clock that just does whatever it does, and you just put it on your desk. But if you get the schematics, you see the software, well then, you know, that could be a draw to an audience, right? Like you could, being more open could be something that brings more consumers to you. I mean, I think a lot of the times is, if you're only going to make 100 of something or 1,000 of something, you know, what's the difference if it's in the public domain or not? Yep.
Do you feel that patents stifle innovation?
Do I feel that patents stifle innovation? I mean, that's a tough question, right? Like, I think that the patent system as it is today is kind of like, so you look at a big company, right? And what they use their patents for is really for defense these days, right? Like, Apple and Samsung have lots of patents, but they don't use them. They don't use them, right? They don't go off and fight court cases a lot. What they do is they use them as threats, right? So it's like, okay, you can't sue me because I have this patent, and I can't sue you because you have that patent. And that's not really what the point of it was originally. The point of it was to give you sort of the first mover advantage, right? If you had a great idea, like way back in the day, was if you had a great idea, then you would want to protect that so that you can have a chance to, like, you know, get some economic profit from it. I mean, in this day and age, things move so quickly that, you know, a phone is obsolete in a year. I mean, like, you know, if patents were to, in this day and age, right, if patents were in full force like that, we wouldn't see a new phone every year, we'd see a new phone every 10 years. So from that point of view, I think so. I think I would like to see more of an open culture as far as the patent system goes. But at the same time, it's like, there's a balance, right? There was a reason that it existed, it's just kind of we've strayed from it.
What tips would you suggest for successfully completing a project from, like, starting from planning to an actual assembly?
So the tips on completing a project, starting from the top, right, from paper. Wow, that's big. So I guess, like, the biggest thing I would suggest is to think through it, but create something quickly, right? Like, iterate is I think the answer. You can plan a lot and you can spend kind of your whole life planning something, but the fact is, like, engineering, I think, is about realizing that nothing's going to be perfect the first time you make it. So you build it, you try it, does it work, you refine it, and you iterate. And I think that's the best way to come up with a finished project. Is that kind of, were you looking for anything more specific than that? Because, like, it all really depends on your project too, right? I mean, work through the big picture. Right? Kind of do the Michelangelo approach is my idea, right? Like, he would sort of take away, you know, create something and, like, reduce it until it's what it is, what it needs to be, right? Like, it's about refinement. Any other questions?
Do you still have that other job, or is your main job now just making circuits?
Yeah, so that's a really good question. I think a really good strategy, and one that's held by, I mean, to answer your question, I am currently still kind of doing both jobs. But and I think that's a good strategy, right? It lets you sort of grow into like doing your own thing, right? Entrepreneurship, it's actually fairly rare, I'd say, for you to like just dive in and do something. That's very risky, right? What you can do is, I mean, there's lots of approaches to it, right? Some people go after venture funding, and like they'll get money from someone who wants to invest in an idea, but you give up something for doing that, right? You give up a bunch of ownership typically. And doing kind of like starting a business while you're already employed helps mitigate that risk. But you have to be a little bit careful about it too, right? You want to make sure that you're not doing things that cause a conflict of interest with your other employer. So it complicates things, and you kind of are forced to grow a little more slowly, but that's not necessarily a bad thing either, right? It kind of gives you the ability to sort of grow at a pace that is conducive to your life choices. Like if you've got a house and a family, it's really hard to say, I'm going to quit my job tomorrow and start this business, right? So it's really about, I mean, if you're coming out of college, you have really no responsibilities, you have some debt from school, it's a little easier to kind of say, okay, let me give this a try right now. So, I mean, the practical thing is, whatever your sort of situation is in life dictates kind of how you can proceed. Any more questions? No? Well, I'm really glad I got to talk to you guys. I think you guys are doing some really cool projects, and I'll be looking for hopefully you guys do some kind of write-ups, and then maybe BlueStamp will link them, and I'll check out the final product. Really cool, guys.
Thank you.